The webinar. I'm going to thank you all for joining us on this first day of December for our webinar on oil and gas data visualization. Please notice our legal disclosure. Materials and concepts that are shared here are current and future product features and are for the event participants only. Sharing and copying them requires Integra's permission. Today, I have Babak Shafi, our founder and CEO, with me, and also Sylvia Lee. I myself am Hoda Rezai, which will be going to present to you our visualization session on Digital Hub. So this series is the last one for this year, but we will have two more sessions planned for the next year. One on January 15th, which will be around a deep dive into machine learning capabilities of Digital Hub, and another one on the January 29th, which will be around the alerting features of Digital Hub. As always, I encourage you to join our community. Our community is a place that the data scientists, engineers, and people who are interested to transition to data science and start their journey in data science can meet, collaborate, and learn from each other and grow with the community. Please join the community and leverage all the resources and the reusable assets that are there for your own growth and knowledge. Now, with that, I'm going to hand it over to Babak for an overview of Integra and also our platform, Digital Hub. To you, Babak.
Thank you, Hoda. Good morning, everyone, and thanks everyone who accepted my invite on LinkedIn. And this is our third session, third quick webinar demonstrating the capabilities of Digital Hub. I'd like to share a little bit of a background on Integra, which is the founder company of Digital Hub, and who Integra is. Make it very short and sweet. We are a boutique, small consulting firm that is focused on oil and gas and bringing AI and ML solutions to oil and gas industry. We've been around the oil and gas industry for quite some time. I personally have been in this space for the last 15 years. And we are trying to fill some of the gaps that exist in terms of the platform, in terms of the community, and in terms of the expertise that we need to bring into the oil and gas to make our industry more efficient and more productive. The experiences that we have in oil and gas are common across all the industries. The platform is usable across all the industries. We just have taken a special interest in oil and gas because this is where we live in Calgary, Alberta, a hub of oil and gas in Canada, and our friends and communities and neighbors and people around us are all working in the same field. Our value proposition is around bringing the big firm experience with the same quality, but backed by industry expertise. This industry expertise is what makes us unique. And our team consists of engineers, like Hoda, data scientists like Sylvia, who understands the industry and the engineering side, and are experts in data science, and they work together to solving real-world problem. And our goal is to bring more and more innovation from the open source community into oil and gas and enable more collaboration. Our expertise in oil and gas, are around production optimization, flow optimization, water user optimization in SAGD, health and safety analysis, inline inspections, pipeline failures, and drilling optimization, and a number of other areas. We have proven use cases in these areas. What I encourage you is to visit Integra website or the community, where we talked about how we solve some of these challenges. These challenges are quick to solve. They're real solvable issues that they can use AI and ML, and we encourage everyone to do it. And that's why we're putting out the community. We realize that changing the industry is not going to come from a small group, but we all need to work together to do that. Another element of what we have brought into this equation is a platform. We realize that a data science platform that is easy to use and has some of the features that we brought in is lacking in this space. There's quite a few of platforms or softwares that facilitates data science process, but there's no platform that integrates all of it together. Digital Hub does exactly that. If you can go to the next slide. What we thought about the Digital Hub, we wanted to have a cloud native, cost effective, and a scalable solution. Why is that important? Cloud native because we want to be able to access it from anywhere. Cost effective is very important because a lot of what we see in data science is try and error, and a lot of the use cases you need to try before you can really get a grasp on what is the hypothesis you're trying to solve and how you're going to solve it. And that means time, and that means resources. So we wanted to build a platform that works on a very cost effective manner, and we have accomplished that, and I will talk to that a little bit. But at the same time, although you want it to be cost effective, but you also want it to be scalable. So if you have a high frequency data like we've done in our use cases, and you need big data capacities, how do you enable that? How can I access hundreds of CPU to solve or model a neural network for a few hours, but then when I don't need those 100 CPUs, I don't want to use them. So Digital Hub brings all of those technologies together to allow you to very cost effectively create your own use cases, use big data, do the data visualizations. And today we're going to demonstrate a little bit of a data wrangling, data pipelining, and visualization fairly quickly. Next slide, please. Who are the personas that we are catering in Digital Hub? There are three groups as engineers, individuals who have really strong background in the business operation. They understand the problem, they understand the phenomenon as a reliability engineer, as a production engineer, so on and so forth. And then they have good understanding of the tool set that they have. But the tool set that they use, most of these engineers, are not the latest and greatest that are available in the data science space. So that's one of the personas that Digital Hub caters to. We enable engineers to access some of the latest and greatest tool sets that is available in the open source community. And data scientists who have the specific statistical and scientific background. We've created and need expert packages fairly quickly. Digital Hub has the ability to bring in all the innovation fairly quickly. Plus the developers who are actually building maybe some intelligence into their platform. These are the three specific type of individuals and personas that we're catering our Digital Hub to. Next slide, please. And some of the features that we have, considered for Digital Hub. The convenience. So there is a survey out, just this year by Anaconda organization that 40% of the data scientist times is spent on configuring packages and putting the environment together. And imagine if you're an engineer and you're trying to transition to data science, you already have a big learning curve in terms of the tools that you need to use, in terms of the techniques that you need to master. How are you going to now come up with the ability to figure out all the different packages with different names and no versioning? Digital Hub solves that. Digital Hub comes with prepackaged, integrated, and secure into a platform. And really, all you need to do as an engineer to access these packages is just run and create a project. And in that project, you can just decide what packages you want to be, and then it will create it for you. Scalability is another aspect that I mentioned. So Kubernetes, and if you've heard of, and Docker is another area that this survey showed is from a skill perspective. Even some of the advanced data scientists are lacking these skills. Therefore, they're having issues moving their work into the production or scaling it. Kubernetes and Docker is what Digital Hub is built on. The scalability and the facility that both of these solutions bring to Digital Hub enables it to be very highly scalable. Teamwork is another element. So we still are looking for unicorns, that have the data science and know the engineering. They don't exist as much over the next few years and maybe decades as people have these combined disciplines, but until then, we need to have data scientists and engineers work together. So teamwork was important, another feature of the Digital Hub. Big data is another important, as we learned through our execution of our project, we realized that setting up a big environment, big data environment, processing it wasn't easy. Lots of reading and lots of Googling and lots of putting packages together. Well, good news is Digital Hub already has a big data environment. You can actually literally log into a big data environment using a Spark, open source. As you know, everything that we use in Digital Hub is open source, and enable that environment. And then the last piece we wanted to add to this puzzle was a central database. We realized that, okay, so when the data scientist does the data wrangling and engineering of the data and the data set, then we needed to move data from one application to another application to another application. We created a central database that becomes a central source of the truth. So a single source of the truth between the engineers, data scientists, and developers, that they can work together. Everybody has access. Every project has access to the same database. So the apps that are used in a given project, for example, today we're going to show the two apps that are used for data wrangling and then for visualization, they run on the same database. Now, the beauty of this is that every project has its own database. So what it means is, from a security point of view, if you have, sensitive data in one project and you're sharing with other people, but you have not so sensitive and you're sharing with some other, these two groups can be completely different. So let's look at the next slide. What enables Digital Hub and what the foundational elements. So we've built a fully automated DevOps backend. So using Kubernetes and Dockers and Helm charts. And what this does for us is that now enables us every new component that we want to add to the platform, we can quickly bring it in, because we want a Digital Hub to be continuously evolving. We realize that every few months there's a new algorithm out, there is a new package out, and we always wanted to try it. We always wanted to say, okay, well, how about this? This Facebook just released this. Can we use that? Can we use that for visualization? Can we use that to train our models? So Digital Hub enables that. From a data store perspective, the persistent volume claims, as well as the Postgres and other databases, are there to enable file sharing. So if I'm doing a project and I have Hora or Sylvia part of the project, I can easily share folders and share files. And then, like I said, the central database allows all of us to communicate and work on the same data set. And finally, on the data science components and notebooks. So we have a series of notebooks that are procedural notebooks. So step by step, they explain what needs to be done. But the idea is that we, through the community and through other work, will bring in more notebooks. But at the same time, you can create your own notebooks. And the next piece that we're adding to this, we're actually building apps. So once you have a model, once you have a data, the end user, that may not be an engineer, that may not be, could be an operator, may need an app, right? So we've so far been showing them dashboards, but then apps can start to trigger actions in operating systems. And this idea of now going to the apps is another very promising idea. The beauty of this is that now your apps are also running in the same data. Your apps are also using the same models that were created in the notebooks, right, in the same platform. So these are the key foundational elements of Digital Hub. Next slide, please. So we have a lot of people registered or pre-registered for Digital Hub. As you know, it's not released yet. We're going to do an early release later this year. And for the early release, we're offering, a free plan for a student. So if you're a student and, you're interested to just, use the notebooks and just learn, we're happy to work with you in the community and offer a number of hours and storage that is free to use. For individuals who are just hobbyists and maybe trying to get into data science space, and they don't want to deal with the hassles of setting up the environment and configuring things, for $14.99 we have an individual plan that you can access Digital Hub and all the notebooks, procedural notebooks that deals with how to connect to Azure, how to deal with time series data, how to build a machine learning model in that plan. The team plan gives a bit more of usage and enables collaboration. And for enterprise, we have the ability to implement it on-prem or on the cloud, and add other features that are specific to that enterprise. And mainly these are, when it comes to enterprise, it's related to fitting that environment into their environment that they've already invested. So we're prepared and we have these capabilities to for the market. So with that, I'm going to go and hand this to Sylvia, who's going to kick off the demo for us and show us how she, as an engineer, data scientist, can run the data and then pass it on to Hoda as engineer to visualize it in a dashboard. Thank you.
Today, demo, we're going to be focusing on the collaboration part of Digital Hub. So how I, as a data scientist, can work on the data, prepare it, and then let Hoda, as an engineer, to come in, access the same data that I've already done all the preparations on, and then develop the necessary insights and dashboards that she needs for the end users or for her own analysis. So I'm now going to log into my Digital Hub. And Digital Hub, being on the cloud, we made it in very convenient that you can just access it from a browser. It's a secure link because for us, security is very important in terms of any data analysis, really. So for today's demo, we're going to be using some data from the UK. So these are open sample data from the UK oil production. And we're going to generate some insights out of it. So I'm just gonna very quickly create a project. I only need Superset for the visualization and JupyterLab for data wrangling. I'm going to add Hoda here as a team member. And I'm going to add Babak here. So the last final step then in this whole project creation process is that I give it a nice name, production data analysis, and a good description on it, so my team member know what this project is about. And I'll give it a few text. So I'm going to generate some BI dashboard out of it. I'm going to do some data wrangling as well. And I'm just going to go ahead and create my project. So because everything is on the cloud, it will take a few minutes for this to generate. And what that's doing in the background is creating that centralized database for you, adding all of the members I've indicated when I create the project into this project, and also launching up the deployment of Superset for you. But for the purpose of this demo, we already prepared a project in which we can show you quickly. So inside this project, again, we have all of these members added, and I'm going to launch JupyterLab. As a data scientist, this is where I'm going to do all of my data preparation process. For the purpose of this data, I don't need a Spark environment, so this is the big data environment. So I'm just going to launch up the default environment here with all of our packages and extensions. In the backend, we've already integrated all of those for you, so some of the useful tools. That is very convenient for data scientists to do their job. So it will take a few seconds here more to launch up the JupyterLab. And so you see here, I actually already launched me into my project folder. So if I go under my projects here, I can see all of the different projects that I'm part of. And each of these is actually a shared folder among all of the team members. So we all have access to the same files here. So these are some of the files that maybe we need some collaborations on. So just reducing some of the hassles needed when we have to do git push or pulling and uploading and downloading from cloud sources. So for this demo, I'm going to launch up this notebook. Just allow me to run a few cells because it takes a little time for the pandas profiling to render. So as a data scientist, I come in, I launch up my notebooks. First thing I'm doing, of course, is loading my libraries. So because this demo, we're going to show you how to ingest data into your database and also do some simple data exploration. So I have my SQL Commit library and also my pandas libraries for the purpose of this. And then, of course, I'm just putting in, this is the centralized data source and the URI from it. And I have imported my data. So this is, again, a public data source from the UK for an oil production site. So I can see there are some field names on here, location. This is the first 5 rows of my data set. I see some oil production, gas production data, associated gas production data, injected water, and water production. And because I see that I do have a date time column here, I'm just quickly converting my data type. And if you haven't joined us for the last session, we do have this feature, this very special package for data exploration called Pandas profiling, in which when I'm just running 2 lines of code, I will be able to generate a very comprehensive report on, in general, just how my data set looks like and all of the variable analysis that I need to do. So for more details of this, you can see our previous sections. So those videos are accessible on our website and also on the community forum and also on our YouTube channel as well. But just a very quick overview. In this Pandas profiling, we get a section showing us very quickly what are some of the perhaps problems in our data sets that we might need to look at, number of variables, what type they are, and for each variable, categorical variable, get a count of every single values in here and some summary data, summary analysis, showing us some period dates. In here, for your numerical data, we have distributions that I can very quickly look at and maybe get some idea of what are some of the data preparations that I might need to do. And so this is just very simply for 2 lines of code. All of these analysis are already done for you for every single variables. Additionally, you can also get very quick glimpse onto the interactions of your data sets between the variables. So how does the oil production look with associated gas or shapeless area, shapeless length? Just very quickly idea knowing where your data is located on a 2-dimensional scatter plot. You can also get a very quick glance of all of the correlations between your variables. That may give you some insight already as to if your data is normal or if there's maybe something wrong with your data. And again, missing values as well and a sample. So I went through that really fast. But for more details of this profile and some of the tips and tricks that you can do in data processing and wrangling, please again refer to our previous videos. So now I've done all of that observation, I've done my data analysis, maybe I've already done some data processing, cleaned it up. So now I need to load up my data set into the database for Hoda to work on. So the next part here, I'm just going to load up this database in my folder here. I see that there's already one table in like this database, but I'm just going to load up this data set that I already have called, and then I'm going to load up called the demo table into this database. And take a look again. So now my demo data is here, and just to make sure all of my data is properly ingested into the database. So all of the code here from this notebook, you can actually access them through our templates that we have enabled for you on Digital Hub. So how do you ingest data into your database, and how do you do those data explorations? So now that all of this is up in the database, I'm going to tell Hoda, I'm done with the data set. The table is called demo. Now you can access it on your Digital Hub. So now I'm going to pass this on to Hoda to show you what she can do with that data set and generating the dashboards.
Great. Thank you, Sylvia. Now I'm going to share my screen to access the data that Sylvia has put into the database for me and show you how you can actually generate your insight using the same data. Okay. Now, again, I'm very easy. I'm going to access my data and my project using a browser. So I'm going to log into Digital Hub. I'm going to log into my account, and I will be able to see my dashboard, which is the projects that I've already created for myself and the projects that are shared with me. That I can see the project that Sylvia has created here, and I am a member, and I can see other team members as well. So, and all the apps that Sylvia has added to the project, I'm able to see them here. For this purpose, I'm going to use our visualization tool that we have integrated into Digital Hub. So it's easy to use for you just with a click on the app. first, I'm going to actually use the table that Sylvia has put into the database for me. So the same data that Sylvia has created, I can see it here. And I'm going to actually go ahead and create a chart. So to show you how you can actually quickly and easily access your data that has been prepared for you, and you can start generating insights and look into, let's say as an engineer, you want to look into different KPIs that you're interested in, you're going to look into different trends. And this visualization tool has many different types of graphs, from the very basic ones like pie charts, line charts, to the very complicated ones like horizon charts. And you can, if your data has coordinates, you can actually put it on a map. For this demo, I'm going to actually create a line chart, which you can see that my data is actually timed, and it has already detected the time data. Then I'm able to filter my time based on the time interval that I'm interested in. For this purpose, I'm going to actually use a no filter. And let's say I'm interested to see what is the oil production trend over the years for all of these fields that I have in my data set. So you see how quickly I'm able to see the oil production trend on all of these fields over the time. You can also add as many metrics as you want. You can add, let's say, your injector waters here. Also, again, the total of it, and then run the query and see both graphs side by side. Let's say I'm interested to see why the injector water has increased over this period of time. I can actually go look into different other graphs, and I can dig deeper into this. But these very simple and basic graphs gives me a general idea, a quick idea of how my data looks like and what are the trends in my data. Now I can give my data a name, my chart a name, which let's say I just call it trend, and then I can save it. Now I can go to the dashboard that I have created for this demo purpose. And because we are actually running out of time, I'm just quickly going to go through some of the graphs that you can actually put into your dashboard. One that is really important for us to generate insights from our data is that to be able to filter our data. I have all of these fields in my data set with like over 45 years of data, but I'm only interested to see one of the fields. Now I'm able to filter my data for only that field, and all the graphs actually are going to be filtered accordingly. Now, in this particular field, I can see my total oil production in million barrels, which is 228.06. I can see my associated gas. I can see my injector water. Here on the right, I can see what is the trend, how my well actually and my field is depleting. What is the peak of the production over the time? And I can see on the graph on the left, why is that? So what happened when I injected more water into my well, what happened to the production? What was the impact of that into my production? And how actually my well is declining and depleting. Of course, there is a lot of other variables involved to actually come to that conclusion, but this gives me a really quick overview of what is happening in my field. Now, it can be done for your own data set. You can have it for your each well and see how each well is producing, what is the impact of your recovery method that you're using on the oil production, and how are the liquids and gas into the well are actually interacting with each other. Now, with that, I'm going to pass it on to Babak to actually close the session.
Thank you for an excellent demo. There was a lot of information packed in this session, but we promised to keep these very short, 30 minutes. We believe everyone who joins us is mainly expert in this area. We do want to generate conversations in the community. If you have ideas, if you think you're enjoying these sessions and you want us to continue, please do reach out to us on the community or LinkedIn. But above everything else, I want to thank everyone for spending this time with us. the beginning of December, and wish everyone a happy holiday and a great season. If you're taking any time off or traveling anywhere, be safe. Thank you very much for joining us.